hope you enjoyed your Labor Day. Okay. When we're coming back, let's first continue to discuss a little bit about Hesse is aggregation and inheritance. Okay. Okay. Can you see clear about this? Is and has right? So we were talking like inheritance. Yeah, we said that's a good thing, right? Because a lot of advantages, like code reusing, and you don't have to redesign something if that's pretty similar. And logically, it helps you to understand like the object, help you to understand the problem domain, something like that. And we also talk about in case you forgot, it's not always a good thing, right? We were like sort of arguing last time. Yeah. Okay. Somebody said it's this way. Somebody says it's that way. Okay. But I hope you are pretty clear of what I want to express. It's not always good. For some situation, you may choose like has a over the is a, something like that. Or for some situation, it's even better to not use object-oriented programming. So, but that's not what we want to talk in this class. Yeah, sometimes if you just want to write a simple function to finish something, like you only have a formula, you want to calculate something, that just need a function, that's it. So you don't have a object-oriented programming, right? So that's why we still have other popular thing that is not so object-oriented, like the MATLAB. Do you think that's object-oriented? That's just some procedural coding stuff. So because that in that problem domain is not as complex as we're doing the actual big software system, big software project. Okay. So there's nothing that is always good. That you have to decide according to that situation, the problem domain. Okay. And we gave that example of the part-time, full-time student, right? Yep. Yeah. So as a summary, like inheritance, when should we use that? It's like should be used to separate the commonality from the specifics. And here I think here's some guidelines. Yeah, here rules for generalization. Okay. When you want to use this generalization thing, you want to ask yourself about these questions. Okay, first is, do subclass B and C make sense as specifications within the problem domain? Okay, like B and C is the subclasses of the class A. Okay, assume this is the assumption, and then you ask, do subclass B and C make sense as a specialization within the problem domain? Within that domain, is it appropriate to have those two subclasses? And does the system need to recognize the difference between B and C? Alright. Although you know that B and C, they are kind of different, like full-time and part-time student. But is it necessary to recognize that difference? maybe you only want to mark that difference by an attribute, right? Or somehow when you only do some certain tasks, okay, you have a maybe female student as a class, male student as a class. Do you want to separate when you give the grade? No, because we equally, right? We treat everyone equally. So no matter you are a female student and male student, we do the same operations. So there shouldn't be any like separations there, right? Not necessary. But maybe some situation you want to do differently, like you give priority to a female student. That's another story. Yeah, you want to separate that. And how are the system's responsibilities for the specializations different? You have to recognize that. The third is you want to ask, will there be inheritance? Like, do some attributes and methods apply to all A's and then specialize into attributes that apply only to B and others that apply only to C? Just there are a whole bunch of attributes in the parent class, okay? Is there something that only apply to B and another set that is applied to C? That actually makes some difference you want to recognize, right? That's still the same thing as maybe the second. You want this kind of separation makes sense. You do not do separation for separation, okay? If you want to separate, you can keep on separate into every different object, even, because if you think about object, every one of us can be an object, right? We can design like student A, student B, student C. We can design more than 10 student class just for this classroom. But is that necessary? No, absolutely not. Yeah, in most of the cases, we don't need this separation. Okay, you need to find the right level of separation that makes sense to this system. There may be some system, extreme case that we need 10 classes for this classroom, but I cannot think of any scenario. Okay, but just you need to, that separation need to make sense. And the fourth one, if the only distinction between B and C, the keywords only, B and C is a type, part-time, full-time, is an attribute. So you can use an attribute to mark that, but you don't need the actual separation of the two classes. Okay. And if the subclasses aids no attributes or method, probably it is not needed, because that's basically replicate the parent class. That's simple. Okay. So do not use the inheritance, or we can call it generalization, just to factor out common attributes if there is no generalization specialization in the domain. So keep the model easy. It's still the same thing. Just yeah, if there's no need, do not do that, right? You need to see the needs there to do the separation, okay, with the subclasses. Sometimes when I do the design, you may fall into this we get some idea that, okay, I'm designing a car system, okay, car system which may be used by a parking lot, something. So as long as I can think of a car, okay, I will think about a sedan, a couple, and the pickup trucks. Okay, I always like, so it's pretty nature. When I think of a car, I can think of different types of car. Compact, bigger one, smaller one. Okay. So sometimes you design a parent class called car, vehicle. Okay, then you have a sedan, pickups, and compact. Yes, it's very nature thoughts, right? Because that's how we realize different cars. Or maybe some student like fancy cars, like general cars. So, but is that kind of separation necessary? That's highly depend on the system you design. If it's like car, a system for like for the system for sale, of course it should be, there's some difference between sedan and pickups. So that's for different usage, and different customers will be interested in different class of cars. Okay, but if it is a system like a parking lot, you see what is in the parking lot? They are all same spaces, right? No matter you park a pickup or it's a sedan, they are in the same large area. So there's not a lot of point to separate the classes. Okay, so it depends on the problem domain. You need to think before you actually doing this separation. All right, that's the generalization. It's not always good. Aggregation. Let's talk more about aggregation. So aggregation should be used to show composite relations. So that's some simple rule. It's easier to understand than the generalization. Sometimes we use a lot of unnecessary generalization. It ends up with some extra classes in your project, but you never use that sometimes, right? Or you use that class only for one reason, for one function, then it's done. Then probably you need to rethink about it. But aggregation, here is a question you want to ask. Test for aggregation. Is the phrase part of used to describe the relationship? Yeah, of course, that's the nature of aggregation. And are some operations on the whole automatically applied to its parts? For example, the delete the whole and the parts are deleted. Like if you remove a student from a class, do you remove the student's bag or something like that? Yeah, I guess the bag or the student's maybe, yeah, anything about the student maybe should be removed. However, there's something you should not remove, like the chair the student is sitting, right? It's not removed. So probably the chair should not be the ads. The chair should not be a part of the student, right? So we should not kind of assign that chair like a part of the student. Okay. And is there any intrinsic asymmetry to the relation? Well, one class is subroutine to the other. Yep. Something like that. Okay, so that's what I want to mention about this generalization and aggregation. Yeah. Well. This is something important. Maybe still you want to avoid like some of the not so good experience when you're doing the design, but sometimes you just those ideas just pop up and you didn't realize that I'm doing this maybe useless inheritance. Yeah, we do that a lot, but with you do more design, you think more, you kind of avoid that. Yeah, so that all requires a lot of experience, work experience. Yeah. Okay, that's has a relations. So I'm not planning on presenting any new materials this week. Yeah, so from next week we will start actually each chapters in our textbook. We will go through that. So far what we have learned is some general concepts of OOD, object-oriented design, right? Yes.
I have a project for this.
Yes.
When does that start?
It's not now. Well, you will know that. Yeah. You will know that. I guess it's in next few weeks. I forgot it's 5 or 6. But yeah, we will see that. Yeah. So and we don't have a lot of assignments after when we are actually doing that project. Then, okay. Where are we? Yeah, we learned some concept, a lot of concept actually, a lot of concepts regarding the OOD, and some terminologies regarding the OOD. Okay. Yeah, and we spend quite a lot of time in doing the ADT stuff, abstracted data structure. Why we're learning those ADT is because it is actually first it's a base of and good example of the object. So it kind of help us to understand the object, how the class, those things work in the computer system, and how that facilitate our design. We're modeling the queue, we're modeling the stack, which help us to solve some problem in the parenthesis match, things like that. And also we learned some refrigerator, ice maker. We kind of look at that example, we model that as an object. So it's a good way to help us understand what is inside an object or the data structure in the object. Yeah, data. We have some data there. We have some operations doing something to those data, and this object or class has a state which is decided by the value of your variables, right? And we can distinguish what is a data in that model and what is operation in the model, right? Think about the ice maker thing. Yeah. So any questions about this part? Yes?
There is a homework due tonight.
Yeah, I do saw some
Yeah,
student asking this, right?
yeah.
Yeah, okay, question?
Is it due tonight? And if it is due tonight,
No, but see, I saw that class on Wednesday 31st, and we didn't have a class on Wednesday 31st.
well, it's,
Yeah,
still,
I thought it's not
it's
a-
not due. It's not due tonight.
Is it due? When is it due?
It's due the 5th.
It's due to the night.
Today.
It's due today, yes. Yes.
I thought the date has to be updated, the homework date, because the date in the.
Also, the 31st is actually our last class, right?
Okay.
Right.
Yeah, but because of the like last.
Okay, is the
time,
it's
I
31st
tried
our
to-
last?
reference to Wednesday. Say
Yeah, so I said
Oh,
the
yeah,
document
it's-
is not updated.
Well, I kind of confused.
If you get
Okay, 31st is EKL, so it's 29.
so wait, no, some of the classes.
Can we have some more time on this, please?
It's a similar modeling notation. Well, what make it so hard of this?
Because this is due today, and I have another class after this, so it's hard to finish.
What particular modeling notation were you referring to in the instructions?
See, if you know UML, you can do something like UML. But here, I'm really not asking you to have a specific format. Just you need to have a way to include this information, right? For you make an arrow pointing up. That's a notation I'm specifying. Like you make an arrow pointing up to superclass. Has you use a line. There's a line off to the set, not an arrow. That's a notation.
So that has to be a separate drawing, right? When it has a relationship, separate.
That's two different relation.
Okay.
Yes, separate.
Okay.
Well, you can do this whole assignment with just like UML, right? Is that what you're saying?
Yeah. And you can do hand drawing. I'm okay with that. So, well, like let's think about this. Complete the vehicle model, right? And label your relations. Like include the 3 levels of generalization. Right? What is generalization? Like what I just told you, right?
Generalization starts with the superclass, right? And you have to solve.
What I made here, generalization, yes. Okay. So as long as there's a subclass and a superclass, there's generalization there.
What do you mean by 3 levels?
Yeah, what do you mean 3 levels?
Like 3 levels of inheritance? Is that what you're talking about? What do you mean by that?
Okay, it's not 3 siblings, it's 3 levels. Okay, so like a vehicle, maybe no, I think, yeah, the root, yeah, top class is the vehicle, right? Yes, vehicle is the generalization, the top class, and down there, motorcycle,
Oh, okay.
cars,
Okay.
bicycle,
And then
tricycle, okay,
Okay.
and you go down
Alright.
3 times, right?
Then
Go
you
down
to the
3 times.
specific. That the last part is that's the lowest level of the inheritance. That's the third, say 3 levels.
Yeah.
For each of them, so for generalization, 3 levels.
Okay, so if it's 3 levels, it's go down 3 levels. So there are actually four of them, 4 level of them. You go down 3 levels, there are 4 level together.
Yeah.
Yes.
For each of that, you have to make multiple, or then you can only extend one more, like to do the 3 levels of aggregation. Do we have to do it for each of those classes, or just the one?
Oh. Yeah, I didn't specify that, but I'm expecting all the level. Like if you have 2 and 4, like 8, that's not a lot, right? 8 to 4, that's not a lot. Yeah.
Sketch.
But if you have 3 and 3 times 3 times 3, yeah.
The level of specialization.
Yeah,
As the last you show us, and say for instance,
Do we
Has
make
a-
for instance, you have a car.
yeah, okay, later.
Okay.
And what's your questions?
On this one, we just draw, right?
You can hand drawing. You can do hand drawing, or you can use any tools.
Can you post like the documents that you were showing us earlier, like in the modules? Because I was trying to look for the slides, like that you lecture off of.
Which slides?
Just the like, so the one that you showed earlier.
Oh yeah, I can post that. Yes.
And then also
yes.
the ones I can't remember if it was last week that you like Shoppo, so
Yeah.
it's kind of like the review side. I couldn't.
Okay. All right, I can do that. Okay, for has a relation. For aggregation, is that your question? For the aggregation, your question is aggregation, right? Has a. Okay.
Or just one.
3 levels of aggregation of one class. Yeah, I specified that.
Of one class. Okay.
Yeah, I specified that. It's not like you have to do it for everyone, okay? It's for one class. You can pick anyone
Okay.
in any level, all right? Like bicycle, maybe the what is wheels? Yes, bicycle wheels. Yeah, you need to think about the next level. What the wheels have.
That's more like
Yeah, as long as you can make it 3 levels.
So that's
Yeah.
like aggregation, right?
Yeah, that's the aggregation. 3 levels of aggregation.
No, my question.
Like I have a head. My head has eyes and the eyes
That one?
has something in there. Yes. The cells. Okay. Cells have a.
So do we have to make like multiple classes of each level, or just one will be fine?
Just one. See, I said of one, right? So it's one. And number 3, one example of classification, an instance, either a vehicle you own or one you'd like to own. Yeah, I think the one you'd like to own is. Yep, it's a better one, right? And include what was inherited. Yeah, so you just have like an instance of any of the project, because the one you'd like to own, it may be a bicycle, or it may be a car, and it may be a pickup, maybe a different brand. Okay, so you can include what was inherited from up level. And number 4, supply at least one attribute and one method per class level. You don't have to show the inherited method or attributes, just the new ones. Yeah.
So in
understand.
essence, you want us to put the unique attribute for that class, and then unique method for that class.
Yeah. Something new. You add it to the super class. Okay. So yes, I think no question for that one. Okay, so you just said you need an extension, or is this you need extension for this simple assignment?
Just 1 day is enough.
Yes.
Yeah. Okay. All right. Let me see.
You always ask for more.
Negotiate. Just give us one hostage. Right?
That's right.
Okay, so I put it for tomorrow.
Awesome.
Right?
Different schedules. Please make it 2 days.
Well, you can make it like in 10 minutes. Okay. Man.
Please, bro.
Yeah, that's too much, right?
2 days.
Well, I think it's fine. Yeah. You have to give yourself some pressure sometime, right, in order to move forward. Okay.
No?
Right? Yeah, we can talk about that. Well, that make it so hard for me. You want extra credit, 2 days, 1 days. Let's just make our life easier. Okay, just 1 day. All right.
Just 3 points.
3 points. Yeah. Okay. Yeah. When I doing the grade, I can kind of I know when do you submit that. Yeah. I will take that into consideration. But how much do I take into consideration? That's up to me. Yeah.
That's right.
But I will take that into consideration. Okay. If you already got 100% there's not a whole lot I can do. But if you're not confident that 90, 99, something like that, yeah, you may find some surprise, something like that. Yeah. Okay. Yeah, that's the modeling homework. Any other questions on anything? If not, I will maybe not. No. Class is not over. Okay. Yeah. See, we have a lot of materials. I can keep talking. Yeah, let's talk about this responsibility driven. Okay, so it's actually something from next week. Let's just take a simple look at it. So object-oriented analysis and design techniques. See, it's techniques, so it's important. You gotta learn some techniques. Okay, so let's see. The two things here, analysis and the design. So how do you understand these two terms? What is analysis? What is a design? What is the difference between them?
Analysis tries to find more information about a problem, and then design tries to provide a solution to it.
Oh yeah, exactly. Have you looked at it already? No, I didn't post it, right? Yeah.
It's more like the requirement.
Yeah, I was hoping this topic can have a 10 minutes discussion, but you just give the answer. All right. Yeah. Analysis, it involves we study the problem, and we're trying to identify what the problem is, but we leave how. Here the keywords how we leave it for the design. So it's a creative process that transforms a problem into a solution. So that's basically how analysis and design. Yeah. So this is citation from this book. Okay. So the boundaries between analysis and the design are fuzzy. I don't know why he called it fuzzy, but yeah, it's okay. Although the focus of each is quite distinct. So analysis will seek to model the world by discovering the classes and objects that forms a vocabulary of the problem domain. Like what we keep on doing, like modeling, right? We identify what is, in the ice maker, we identify all the vocabularies, keywords, operations, those keywords. So we're trying to find what is there, what should be included there, what's the relations there, right? And in design, we invent the abstraction and the mechanism that provide the behavior that this model requires. Yeah. So we kind of give more detail of how we solve that problem. Maybe some I think relations should be in the design. So in the design, we try to define those relations, okay, and how different things they connect with each other, and maybe some of the algorithms to solve a actual problem. Yeah. Because after we identify the problem domain, we have a whole bunch of ways to model that problem domain, like the vehicle example I just mentioned, right? So we can model the vehicle, the subclasses, sports car, general cars. We can also model with different type, SUV, sedan, something like that. that's actually is decided in the design stage. So how you model them. But in the problem analysis, we design what are in there. So, and then the design, we define how do we model them. Yeah. Okay. What is this? Yeah, is there some like historical of the thing? Okay, so object-oriented design, object-oriented analysis. See this point. In the middle 1990s, there were over 50 complete OOA methodologies to choose from. But UML, yeah, it's like the standard there. However, we maybe use UML a lot today, but still there are a whole bunch of different methodologies, which is pretty similar, which they are pretty similar to the UML. Okay. Yeah, and the first of them is published in 1991. Okay, that's pretty interesting. That's kind of late, right? 1991. So 1991, I think PC is already pretty popular, right? Yeah, it's later than I thought. Yeah, object-oriented analysis and design has evolved. Yeah, of course. And UML and Boch's methodology assume a familiarity with the object-oriented analysis and methodology. So there are two different methodologies of the OOD. Yeah. Not consequence. Yeah, there's nothing important here. Right. What I want to talk about is this: identifying class and objects. So there are two kind of design. We need to compare. First is identifying the classes and objects from this informal English description, right? Another one is called responsibility-driven design. Responsibility-driven design. Let's see what are these and the difference. So informal English description. So what you do is just write an English description of the problem and underline the nouns and verbs. And consider the nouns as a candidate object. Consider verbs as candidate operation upon the object. So that's pretty straightforward, and it's easy to understand, right? Of course, the verbs they are operations, and nouns they are object.
I know that object is an instance of a class. Shouldn't the noun be referring to the class instead of object? So you say this class and object. Kind of,
Well, class is something abstract. Object is something solid. So when it reaches the problem, when you're solving a specific problem, right? There, most of the time, there's objects there. When you reach the class, that means you are doing some like generalization or something like that in your mind. So you form that classification, categorize them. It forms a class. Okay. So anyway, but objects come from the class. Okay. Objects comes from those classes. They're instance of the classes. So when you're saying that object does something, it's actually because of the class has that operation. So it's still the same, right?
It's the same, but in a lot of lot of books will be talking about when it comes to textual analysis. They talk about identifying classes and identifying methods using nouns and
Verbs.
that's what the point of that.
Let's see. Yeah, here I think here the object, from my view, is same as the class. From my view, yeah. I don't know is there any specific reason they stated as objects, but it's actually referring to the class where the object come from. That's what I think, yeah. So the verbs is an operation, and the nouns are object or class, whatever you want to call it. So yeah, a whole bunch of advantage in this strategy, right? It's pretty straightforward. It's easy. Help motivate developer to think in the vocabulary of the problem. So facilitates brainstorming and helps generate an initial list of objects. Brainstorming, the initial list of objects, and can be automatically processed. That's pretty fancy, because given that the AI is not pretty awesome like 10 years ago. Okay, if you have some this kind of thing, you can just read through a text, identify the verbs. It doesn't require a lot of AI, right? So it can automatically read a paragraph and identify the operations and the class. That sounds pretty awesome and save us a lot of time, right? So that's one of the advantages. But the quality, yeah, I don't think that quality is good enough. Of course, it has plenty of disadvantages. Otherwise, we won't talk about other strategies. So disadvantages here, it relies on the writing skill of the author to precisely state the problem. I agree with this, right? You can state the problem that no one can understand. If no human can understand, you cannot expect the computer to understand that. Okay, and regardless of how well written the document is, any document written in English or other natural language is inherently ambiguous, okay, due to the language itself. All the high-level language, like language we are speaking, they are pretty ambiguous. Okay, I mentioned this point a lot in the formal specification class. That's why we need a formal specification. It's a mathematic way to express what you mean to the computer and remove all the ambiguity in the natural language, right? Yeah, I'm thinking of example of ambiguity of our natural language, but I forgot. So can you give an example? Ambiguity of maybe English.
You can say push the table, but it doesn't tell you how far you should push it or how strong you should push.
Okay, that's not
Kind of vague.
well, that's not like the ambiguity I'm referring to. That's like it's not specific enough, not detailed enough, right? The ambiguity is like you can understand.
different things.
You can understand either way.
Read and read.
What's that?
Read.
Read.
So you
Read
read a book and read a book.
a book.
I've read.
And read. Present and past.
Oh, you mean the pronunciation is
Yes, it's the pronunciation is.
well. I think two of you come from my formal specification class. I give a lot of example of ambiguity, but I cannot think of any right now. You're supposed to remember that, right? Well, I cannot remember that because I'm not a master of English. Yeah, I have a lot ambiguity example of Chinese right now in my mind, but I cannot just translate that because after I translate, it's not ambiguity at all, right?
It can be like you have to turn right, or it can be like right can mean you have to turn correctly, or you have to turn right.
Oh yeah, something like
I like
that.
the word grave, like it can mean where someone's buried, or it can mean
Yeah.
something very serious.
Yeah. So
Yeah,
that's
yeah.
the one. Yeah.
I'm thinking of a sentence that like when you have a one sentence that you can understand that sentence different way.
Like, let's eat, Grandma. Like,
Yeah.
give me like, let's go eat, Grandma, or let's
eat
eat,
food,
Grandma.
Oh yeah, yes. That's that's one of the example. That's a
Drama this.
that's a horrible example though.
Yeah.
Well, that's an example from the Little Red Riding Hood. Right? Good. Yeah, that's a good one. Okay, so that's the ambiguity of natural language. All right. Okay, so well, another thing we want to talk here is like the responsibility-driven design. So responsibility-driven means we have the delegation of responsibility for those operations. Okay, we kind of want to focus on building a model of interacting object before filling out the precise details of each class. So we focus on maybe the interaction between the classes. We focus on the operations first. Then we go to the details of the classes. Right? We don't identify the class first. We identify the operations or the interaction in this problem domain first. So right, involves reducing data control dependencies between modules and designing. That's something information hiding. It's one of good thing we need to do in the object-oriented design. So the philosophy here behind is that no action can take place without an agent, object, or class, okay, performing that action, right? We agree with that, yeah? Like grade the assignment, this function, right? We identify this operation first, grade, and then we need a kind of agent to do the grade, right? Okay, we want a system that grade the student's class, grade the student assignment. So we need some agent to have this functionalities there to do this operation.
So if you have the operation is still within a class, right? So the class will be delegated to handle the operation?
No. We don't have a class yet. Now we only have operation. And then we decide which class should this operation goes into. Is that clear?
Okay.
Right? We don't have a class yet. We first identify the operations. Yeah. Central focus is establishing who is responsible for each action. Yeah. That means the operation should goes to that agent. And some tools to help with that. So the CRC card, the CRC cards class responsibility collaboration. Okay, so it's an object responsibility, a high-level statement about the knowledge it maintains and operations it supports. And collaboration means the request made by one object to another. It's more about at least two classes, objects. Yeah. And responsibility is kind of higher level. It's like in this object. Yeah, what is the main responsibilities? What main responsibility? It can include whole bunch of operations, like a teacher class. Okay, it may include grade, right? Lecture, giving lecture, send an announcement, a lot of things, like teaching, research. Okay. And teaching research is actually pretty high level description. And then if you go down teaching, you have a lot of specific operations, right? Lecture, giving lecture, and giving grade, something like that. Okay. And this is called CRC card. Each class is a CRC card. What CRC stands for?
Responsibility, collaboration.
Yeah, that's great. Awesome. Yes, class responsibility and collaboration. So this is something looks like the CRC card looks like something like this. So we have a class. So this is for one class. Okay. It has a super classes. So what is its parent classes, and what are the subclasses? Yeah, so if you're using UML, this kind of relations is indicated by those arrows, right? But here it's pure text. Okay, I'm saying it's pure text. So you have to specify what is its subclasses. Maybe it's inherited from 2 classes, and it has 2 subclasses. Okay, or 3. No, so you specify them. Superclass is not yes.
Why the superclass is not at the top? Because superclass, subclass will share.
Yeah, it's a good question.
On them.
I think it doesn't matter, right?
It doesn't.
I mean, maybe
It does it matter?
Maybe that's the format.
Yeah, I think yeah, just a format. I cannot think of a particular reason you put anyone on top of another.
Ideally, since especially when we talk about the hierarchy, ideally the superclass should be on top. And the subclass should be.
No, this card is for each class.
It's for each class. So if the class belongs to a super class, then you have to state it in the card. I
Yeah.
think that's what it is.
Well, yeah, I need to check if there's any particular reason. But as far as I know, I don't think that matters. Okay. Choose meaningful names. Sure. Yeah. So you have class name here, and then you put on all the subclasses. See, they use classes here now. Here, this object. So class and object here is basically referring to the same thing. The object means that class this object from. It's from. Yeah. Choose meaningful names. And let's see. Yeah, and it has 2 slots. One is responsibilities. One is collaborators. I just specify them. What is its responsibility? The problem to be solved. What is the problem that this class is going to solve, going to address? And use short verb phrases to describe the responsibility. What is to be done, not how it is to be done. Yeah, because it's in the level. It's not in the implementation level, okay? And view them as a contract. They should fit in the card. May require moving responsibilities or dividing the task. And collaborators is the classes that has some connection to this class. just all classes of which the class needs to be aware. Must include all classes that provide services. May include classes that require service provided by this class. Okay, this must and may. Alright. So must include all the classes that provide service. Why it's a must? Because when this class provides some service operations, it may depend on the service from other class. If that information is missing, you cannot achieve the responsibility of this class. Okay. And may include classes that require service provided by this class. Yeah, it's may include it. It's good if you include it, but if you doesn't include it, this information is also available in the class that uses class, right? Yeah. So if you include it, it's okay, but if not, information is still there, not missing, right? Always. All right. I think I'll stop here. That's a lot of things to talk about. Yeah, so something from next week. I want you to get a little bit familiar with that so that we can do it more quickly next week. But for today's class, the main thing is I want you to ask any question you have regarding whatever we have learned in OOD. But actually, we talk a lot during class, right? Questions. Still any questions on that part? Any part? Except for the deadlines, assignments, extra credit, things like that. Okay. All right. Good. So, right. So that's it for today's class. We will continue to talk about this OOD next week, and we will have more fun next week. All right. All right. Bye. Thank you.
I started mine.
Yeah.